Welcome everyone to the day 4 of our 5-day workshop on credit risk scorecard using logistic regression technique. In our last session, we had built a single variable logistic regression. We regressed our target variable with respect to gender, the code for the regression in Python. The snippet of that code is given here. The coefficients table output is given here, and how to calculate the probability was explained in the last session. So let's continue from where we had left in our last session. I'll move to my Jupyter notebook and let us quickly execute the codes we had executed last time. We'll import the pandas package. I'm not going to run the OSCHDIR because the file which I want to import is in the same folder from where I launched Jupyter Notebook. This is a shape. We have 20,000 records, 27 columns. The head, initial few records is what it is displayed. The list of columns, if I want, I can get a listing of all the columns. And this is the code we executed here for target variable. In the last session, I mentioned that here it is our p-value, and that p-value is basically tells us whether the variable is significant or not, and based on this p-value, the gender variable is not significant. This is where hypothesis testing in machine learning model development, hypothesis testing is a very essential and important part of model development. So let's understand hypothesis testing and importance of hypothesis testing. So let's understand why hypothesis testing is important. When we typically build machine learning models, we typically take a sample from the population, because whenever we build a model, we are not going to build model on the entire data available. We will take the entire data, whatever is available for last 2, 3, 5 years, and from that data, typically what we do is we take a development sample, validation sample, and holdout sample. We break that data into 3 samples: development, validation, and holdout. And then we run regression on our development sample. And when we are running a regression on development, we have certain hypothesis. What is hypothesis? Hypothesis is an assumption. It's a conjecture. It is your opinion about the topic. Now, if you are building a scorecard for credit risk, you have to ask a question to yourself: what are the factors which influences the default behavior of a customer, or what are the factors by which I can identify which customer is more likely to default or not? If I say the probability of a customer defaulting depends on gender, whether the person is male or female, and I make a statement: male are more likely to default as compared to female. If male person takes a home loan, they are more likely to default as compared to female. What is your opinion to this statement? What would be your opinion? Suresh, Aniruddha? Yeah, Suresh or Aniruddha. I'm asking a simple point of view. I'm making a statement, I'm making an opinion actually. Male are more likely to default if they take a home loan as compared to female. What would be your opinion?
Probably because I think you are taking into consideration the dependencies when it comes to the
Yeah,
male, whereas with the female, the dependencies are not
yeah,
that
okay,
prominent.
yeah, okay. Uh, Suresh?
I mean, you are making, you're making the statement. Yes, it can be making by taking the previous data or history data taking into consideration.
Yeah. So basically, when you're making a hypothesis, it is a assumption, it's a opinion, and that opinion is actually made based on a limited evidence. Okay, probably I would have been handling many loan application forms and I would be dealing with many customers, and most of the time I see that the defaulter is a male, and the collection person has to go out and collect money, get the money collected back from male. Okay, and just because of those kind of experience, my opinion is male are more likely to default. Now it's just an educated guess whether this opinion is true or not. I really don't know, and you have to ascertain the truth of this opinion by something called as hypothesis testing. And hypothesis testing, it's a very important part of machine learning model development. If you really have to be a successful data scientist, you should really hone the skill of hypothesis development and testing. Okay, now let's just take this, and I am building a model. I have been given a data set and I framed a hypothesis that male are more likely to default compared to female. Let's see what is the fact. If I see the actual data, the default rate in female is 6.87 and default rate in male is 7.01. I can see there is a marginally higher default in male, and the marginally higher default observed in male is about 0.14 percentage. Do you think the difference between the default rate and the default rate between male and female is significantly different so that my statement is validated? Just by seeing this number, default rate male is 7.01 and 6.87 in the female, do you think it really, my statement is really true that males have a higher default rate compared to female? Yeah, Sharad?
No, sir.
No, right?
No.
Now, now in this scenario, the numbers are very close to each other. So by default, upfront, we can say my hypothesis is not true. However, the thing may not be so transparent and so glaringly evident to conclude whether the hypothesis is true or false. Okay, it may not be so glaringly visible. In that case, what you require is a statistical approach of validating the hypothesis. There are various kind of hypothesis tests. There are various kinds of hypothesis tests. Something like Z-test, T-test, ANOVA, one-way ANOVA, multi-way ANOVA, chi-square test, and there are many such uh, hypothesis test. Now, in simple way, if you have come across the term of hypothesis testing for the first time, a very simple analogy to explain what a hypothesis test is: you go to a doctor and you have got some fever, and sometimes you feel cold also. Given your symptoms, doctor feels that at times you are feeling very hot, at times you are feeling very cold and shivering, doctor feels you have got malaria based on symptoms. But nowadays, doctor, just by seeing symptoms, they don't end up giving medicines. They really want to validate whether you really have a malaria or not. So what is doctor going to do? What is doctor going to do? Doctor is obviously going to suggest couple of medical tests, blood tests, urine test, something, right? Now, whatever is the prescription, based on that prescription, you go to a pathology lab, and in that pathology lab, they will take a sample. We are using a sample to derive inference about the population. So your blood sample, based on blood sample, they don't suck out the entire blood from your body. So the entire blood flowing in your body is population. They take a sample, they test the sample, and based on that test, they give you a test report which says that whether you have got malaria or not. The test that you are conducting, similarly in statistics, just like we have different types of blood tests, there are different types of statistical tests. Just like a doctor has a opinion based on your symptom that you may have malaria, similarly, when we are building a model, we have an opinion that this variable can influence the target phenomena which we are trying to predict. And to validate our opinion, we make use of some statistical test or called hypothesis test, and that hypothesis test gives you certain output. And based on that output, we conclude whether the hypothesis is true or not. So here to validate whether the hypothesis is true or not, the logistic regression is making use of a test which is Z test. This Z is actually a Z test. And this is the P value, where my mouse is now putting a tick mark. That value is a P value. For gender, the P value has come out to be 0.811. Can you tell me how to go about inferring this P value 0.811? Aniruddha, Sharad, Suresh, all three of you. How to infer that P value?
So now depending on the confidence level, let's say if we are considering 95% confidence level,
Yeah.
so the p value of less than 5% is considered significant.
So we have to set alpha, that is alpha threshold, and typically alpha threshold we will set, say we have set alpha threshold of 0.05. That's a thumb rule. But in modeling, we typically set risk modeling, we typically set is 0.0001. For now, I'm just going with the general thumb rule, alpha threshold of 0.011. So based on that, is gender variable significant, not just significant?
Not significant.
Not significant. Aniruddha, you know the term, this hypothesis testing?
I don't remember actually.
Okay. So this alpha, typically when we do a hypothesis test, as Sharad was mentioning, we need to set a confidence. Okay. Now alpha is equal to 0.01. If alpha is equal to 0.01, in that case, confidence, I'll just write CONF. Confidence is equal to 1 minus alpha. So what we are saying is, I want to take any decision at a confidence of 95%. 1 minus 0.05. 1 minus 0.05 is 95%. 0.95, I'm converting that in percentage terms. So what it is saying that any variable that I select should be at a certain confidence of 95% or above. Now in this place, the p-value has come out to be 0.811. If the p-value has come as 0.811, the confidence that I have in the gender variable will be 1 minus 0.8, that this variable is significant. 1 minus 0.8 is 0.2. That is only 20%. But I am saying that any decision I take, I want to take at a confidence of 95% of above. And here gender is coming at only 20% confidence. So the way I would say is, I'm only 20% confident that gender variable is significant. Now, if I'm only 20% confident, in that case, for me, the gender variable is insignificant. It is not significant. Okay. So hypothesis testing is used to validate our hypothesis. I once again repeat the analogy. You go to a doctor, you've got certain medical ailment, doctor observes you, sees your symptoms. Based on symptoms, doctor feels you have got a particular medical problem. It is hypothesis. At this point, based on the symptoms, doctor is making an opinion you have got a particular medical problem. Doctor suggests you a test, you go to pathology, you get the test, report comes, and based on the report, it is concluded whether you have got that medical problem or not. Take the same analogy to data science. I have an opinion, a particular variable influences the target phenomena which I am trying to predict. Based on my opinion, I apply a hypothesis test, a statistical test. A statistical test gives me a report. Based on that report, I conclude whether my opinion was correct or my opinion was wrong. In this case, my opinion is wrong. Gender variable is not significant. This is how hypothesis test is applied. So now, whenever you are building a model, you have to frame hypothesis, and the way hypotheses are framed are there are always two statements. One is a null hypothesis, other is alternate hypothesis. When we are building models, we always frame the alternate. We always want the alternate to satisfy. Null hypothesis is variable is not significant. Alternate hypothesis is variable is significant. If the variable is comes significant in your model, in that case it will be part of your equation. If the variable is not significant, it means the variable will not be part of your equation. Now, finally, if you want to end up having an equation, y is equal to alpha plus beta 1 x1 plus beta 2 x2. If you want an equation to form, you require certain x1, x2, x3, some of the independent variable, also called as predictor variable. You want some of the at least a few of the predictor variable to come significant. If all predictor variables are insignificant, your equation will become y is equal to alpha constant, y is equal to constant intercept. If y is equal to intercept, which means you do not have any model. So in a very simple term, when we build a regression model, what is null hypothesis statement and what is alternate hypothesis statement? I'm now making those statements. At a model level, I'm making the null hypothesis. Null hypothesis at a model level in regression model is all the independent variables are insignificant. At a model level, I repeat, the null hypothesis when you are building a regression model, the null hypothesis is all the independent variables are insignificant, which means you cannot build a model to predict the target phenomena. As simple as that. Alternate hypothesis is at least one of the independent variable is significant. I'm not saying all variables are significant. What I'm saying is there is at least one variable out of all the independent variable which is significant. There can be more than one. Alternate is saying there is at least one variable which is significant, which means I can build a model and predict the target phenomena. That is what the alternate and null hypothesis are for a regression model. How do you frame hypothesis? How do you frame hypothesis? To frame hypothesis, one of the thing is you require certain domain knowledge. Okay, the starting point is to get an understanding of domain or the business problem at hand, and that is what we did in our day 1 workshop. And based on the domain knowledge, you start making hypothesis. Now let me explain a hypothesis. We'll all make a few hypotheses. These are my columns in the data set. What are we trying to predict? We are trying to predict the phenomena of default. Now let me take a variable. Residence stability, years in current residence. One of the variable is how many months, years the customer is in the current residence who is applying for a loan. How many years the person is in that residence. So my hypothesis is a person in a given locality, longer the tenure, longer the duration, less chances are that customer is going to default. Higher the residence stability, less likely the customer is going to default, is my hypothesis. If I ask Sharad to make a similar hypothesis but use the variable fixed obligation to income ratio, so what would be your hypothesis, Sharad?
So higher the FOIR, higher the chances of default.
Higher the FOIR, higher the chances of default. Okay. Suresh, LTV, loan to value.
Loan to value, higher the loan, higher the defaulter.
Yeah, higher the loan to value ratio, which means you give a higher loan amount against the property, more risk you are taking, as such the chances of default is higher. Yeah. Okay. Aniruddha, age. What would be your hypothesis on demographics? Age. Assume youth, middle aged, old age. There are three kind of age segments.
So I would say that the higher the age, the chances of defaulting is high because the number of years where they have to pay back the loan will reduce with age.
Yes. Yes. So the people who take a home loan at a higher age are more likely to default because the number of years of earning is less as compared to youths. A youth, and at the youth stage, your income also increases very fast. At an older age, income does not increase very fast, right? Someone starting at 2022, in the initial years, the person can get 30, 40, 50% year on year hike for next 5, 6 years. But after that, the growth rate tapers down and it is 5%, 2%, 10%, and sometimes it also goes negative in COVID kind of scenario. Yeah. So these are hypotheses. All of these are our opinion. I hope you all of you are getting. None of this is validated. It is our opinion. Now, how this opinion we have? We have this opinion based upon our generic knowledge, our wisdom. But we have to validate this opinion with data based on whatever data is available. Now, let's see LTV. this is a single variable logistic regression for gender. We have already made it. So let's make a model for LTV. So here I'm saying target tilde LTV. I run that. Now this is the summary output of target as a function of loan to value. So let's see what is the p-value of this. The p-value of LTV has come out to be 0.000, 0.000. Assuming alpha equal to 0.05. Alpha is equal to 0.05, or probably now I'll say alpha is equal to 0.001. Let me take this 0.001. If it is alpha is equal to 0.001, which means my confidence at which I want to take a decision is 1 minus 0.001, that is 99.99% is the confidence at which I want to select the variables. Now, if that is the confidence at which I want to take the decision, based on that, is LTV significant or not? Is LTV variable significant or not? P-value of LTV is 0.000. Let me know. What's your opinion? Sharad?
It is significant, sir.
It is significant. Why? The p-value has come out to be 0.000. So the confidence is 1 minus 0.000, which is almost 1 minus 0.00. It is basically, it is showing only 3 decimal, but it is a number very small. So 1 minus 0.000 is 1. So my confidence is virtually 100%. And this confidence is above the 99.99 threshold that I have set. Okay. Now, the p-value, based on p-value, this variable is significant. However, the way we phrased our hypothesis was, higher the LTV, higher is the risk of default. Now, higher the LTV, higher is the risk of default. What it means is, on x-axis, I have LTV. On y-axis, default. Default is our probability. So on y-axis, I've got probability. I should have a data, if I make a scatter plot of LTV versus probability, I should have a graph something like this going upward. Do you agree? Aniruddha, do you agree? If I make a plot of LTV versus probability of default, I should get a graph which is an upward moving graph.
Yeah.
This is because this is what our hypothesis is, right?
Oh.
If the graph is upward moving, can I say the correlation between LTV and probability of default should be a positive correlation?
Yeah.
So I can also say, in that case, the equation between z where z is nothing but log of odds. I'll just put log odds. Log of odds is equal to z is equal to alpha. This alpha is not this alpha. Okay, don't mix the two alpha. This is a significance level, and this alpha is basically, or let me put it as a plus b1. b1 is a beta coefficient, LTV. The b1 should be a positive coefficient based on our hypothesis, right? If b1 is a positive coefficient based on our hypothesis, the coefficient in the equation should come positive, and here the coefficient is coming positive. The p-value is saying the variable is significant, and the coefficient is showing that the hypothesis statement that we made, the beta coefficient of LTV is in that direction because the coefficient is a positive term here. All these things are to be observed very granularly when you are making a logistic regression model. The summary table which comes up in a logistic regression model has to be seen very granularly, minutely. Lots of inferencing has to be done. Okay, so based on that, I've tried to explain a hypothesis of a logistic regression. I've tried to see whether the variable is significant. I'm also relating that our hypothesis statement is as LTV increases, the default probability should increase, and that is positive correlation statement we are making. In that case, the coefficient should come positive. We have to check all of this when we are building a logistic regression model. Okay. Yeah. Okay. Now this is a summary output of a logistic regression. There is an importance of something called visualization also. When we build model, I just made a XY axis and made a plot. But it is equally important that we should visualize data. Okay, how the trends are. So let me explain how to go about doing visualization. Definitely there would be automated codes of doing visualization. And you can write automated codes in Python. You can do automation with Python and VBA Excel. At this point, I'm not going to automation because my focus is explaining the concepts. We were focused on this LTV variable. This is the actual data which we imported, and this is the actual data on which we are building model. For now, our focus is LTV and target. These two columns are our focus. I want to visualize this data. However, LTV target is 0, 1. So it will be difficult to visualize. Even if you try to make a visualization of this two, saying, okay, I'll make a scatter plot, insert scatter, the data will come something like this. The plot will come something like this. Why? On one side extreme, the value of target is 1, on the other extreme, it is 0. So you get a plot like this, you will not be able to make any sense out of this plot. Okay. So to make sense out of this plot, how do you do it? To be able to make a sense out of this plot, what we need to do is, we need to convert the LTV into LTV buckets. So what I'm doing is, I'm just creating LTV and LTV bucket here. Just a mapper table. And I'm using a VLOOKUP functionality. Okay. I'm using a VLOOKUP functionality where I'm saying that VLOOKUP 75 in this table, and based upon the value of LTV, it will choose the appropriate bucket. So if you see, I selected 75 and I've done a VLOOKUP. This 75, it is taken 75 to 80. This is 60, 66. It is taking the bucket 65 to 70. 59, 50 to 60. And for 0, I have said less than 50. So 0 here, see what it does is, from this to this range, this bucket will go. From this to this range, this bucket will be taken. Reason is, I'm using a VLOOKUP, and here the last parameter is actually true or false. I am passing true, approximate match. After this, I'm saying 1. 1 is actually approximate match. I'm not saying that, hey, when you're looking 75 in this range, if you get 75, only take that value. If you get 66, only take that. I'm saying whichever is the closest number you get to 66, take that bucket and populate here. Okay, so first step, I'm converting the continuous number to bucket. Now what we'll do is, we'll quickly take this entire data, insert, pivot table, okay, and I'm not bothered of any other variable. I'm more concerned of this LTV buckets. I'll put here, I'll take target, I'll put target, few field settings, count, okay, this is my data, control C, control C, I'll just make it Alt ESV, paste spatial values. This is LTV LTV bucket. This is 0 are good customers, or let it keep 0 and 1 only, and this is grand total. So bucket wise PD, and this is greater than 90. Let me let it be there only anyways. And this is, I'll have to sort it. So let me say somewhere GT greater than 90 and move it probably down. I don't require grand total, it's okay, because I'm going to make a plot. PD, probability of default or default rate. Okay, so let me call it default rate for now. Default rate, bucket wise default rate 61 divided by total in that bucket. And we can make a plot of this. Insert a plot. No, it's not come proper. Yeah, I'm just making a plot. I'm going to make a double axis plot to explain the data. Control up. You can then probably see the video once again to understand the steps. I'm trying to make optimal utilization of the time. I'll change the series chart type of the second plot, and I'll make it default rate on a secondary axis. I'll put it on secondary axis and I'll make it as a line plot. Okay, so add data label. LTV versus bad rate, default rate. Okay, here we have our graph. Make it big so that you can clearly see on your screen. This is the default rate. So quickly, what I've done is a data which was in number of rows, I've shown it in a visual format, and the visual format is in line with our hypothesis. As LTV increases, the default rate increases. This is very clear from the trend. The same thing is shown in the coefficients, and because the trend is so glaring, this trend on one extreme, you can see the default rate is 2.20. On other extreme, we have default rate of 11%, and there is an upward moving trend. This trend is clearly saying that where the LTV is very low, we have less default, and where we are giving more loan amount compared to the property value, which means we are taking a higher risk, the default rate is going to be very high. And obviously the visual chart is saying the variable has to come very, very significant, and this is evident from the fact that the p value of the variable is 0.000, which means the confidence is almost 100%. So this is how you typically do things when you are doing a logistic regression model. You make visual charts, you run the regression, you see the p-value, you see the coefficients, and based on all of this, you validate your hypothesis. How significant is this variable, and what is the trend of this variable? Is the trend in line with the opinion that you have? Okay. Okay, so let's get back to our Python Jupyter notebook. Okay, so this is where we were. So what we can do is we can take this coefficients table, copy it, paste it in Excel. I already done that. This is where my Excel is. Okay, so I've taken this output and taken this entire table. Whenever you run regression, you always remember you should see how many observations the model is considering. You're supplying 20,000 observation. Is it taking all the 20,000? If any column has got any missing value, in that case, the number of observations will go down. Okay, so it's very important to see some of these basic numbers, and then definitely it is very important to interpret this coefficients table. Now the coefficients table, let's now compute p-value for a continuous variable. Okay, last session we did p-value calculations for a categorical variable. Now this time let's take single continuous variable and do the p-value computation. I have got LTV 80, 81, 82, 83, something like this. Okay, so what will be the, let me increase Control Z, let me increase the width of these columns and also increase font in Excel. Yeah, so if LTV is 80, what will be the Z value? Because our equation is log of p upon 1 minus p is equal to z is equal to 1 plus alpha plus beta 1 x1 plus something. So I'm saying z is equal to log odds. So what is that z? So the equation would be something like this. Z is equal to alpha, which is the intercept, plus beta 1. The beta 1 for LTV is 0.0347 into, if a customer is applying for a home loan by taking the loan at a LTV of 80%, which means the customer is making a down payment of 20% from his pocket. In that case, what will be the p value? In that case, first we compute the z, and this z we then convert to p by taking 1 upon 1 plus exponential of minus z. So the p value, the probability of default, will come out to be 0.09, in percentage term 9.78. What is our default if this is 81? If the LTV is 81, once again the equation remains same. Intercept plus 81 times LTV, we get the z, the log odds, and we once again do p is equal to 1 upon 1 plus exponential of that number, and that is 10.1. So here you can clearly see as my numbers increase. So I'll just do a copy, paste, and let me put some 50, 60, 70. So here you can clearly see when LTV is 50, my model is saying the probability of default will be 3.69. Where's that graph? 50. Here, the model is saying it will be less than 50. It is saying it will be 2.20, less than 50. So let me make a value, one value less than 50 also. 40. Something. Okay. So if it is 40, I have 2.63 default, 50, 3.69, 60, 5.1. It is clearly showing that this is increasing. Okay, 80, 81, 82, and let's put one more, 90. Okay. Now the point is, at 90, I'm saying 13%. But the trend is saying at 90, after 80, the trend is flat. The trend is flat. So here there are certain concepts like variable transformation. Based upon the trend, you do some variable transformation, capping, flooring, all of these concepts of machine learning model development will kick in. Okay. Uh, at this point, I'll not get into detail, but the problem I hope you are getting, after 80, this trend is flat, which means any value above 80, I should assume it to be 80, and I should create a new column, LTV capped. I should create a new column, LTV capped, saying that if LTV is more than 80, for the model purpose, we should consider it 80. Otherwise, what will happen is we will give a very high default rate for 90, 100, or you may say that really speaking, the trend should have been like this. The trend should have continued to be like this, but because of our lending policies, we have been stricter in this zone in evaluation of these loans where we have given higher LTV. We have been relatively stricter in evaluating, and because of those policies, because these loans have gone through multiple reviews before a high LTV was given, that's why we are not getting this kind of a trend, upward, continuous upward trend. So, but theoretically, from a real business point of view, the trend should be a upward moving trend only. As such, I will not cap at 80. I will assume that what the equation is giving me, a higher default rate for 90 as compared to 80 is right. As such, the model, this variable is accepted without any transformation. Okay. Just a last point. This value, you can see z is equal to log of p upon 1 minus p. So this value, what I have computed is log of odds. So I'm just highlighting log of odds of 80, log of odds of 81, log of odds of 82, and then I'm computing here the difference. I'm computing, and this is 83. I'm computing the difference between the log of odds of 81 and 80. Then I'm computing the log of odds of 82 and 81. I'm computing the log of odds of 83 and 82. This value is same. And if you see this value 0.0347 is matching with your coefficients. So what the coefficient is saying, that the coefficient of the model predictor variable LTV, which is 0.0347, is saying that for every incremental unit change in LTV, the log of odds will increase by 0.0347. This is a technical understanding of the coefficients. The technical understanding of the coefficient is for every incremental unit change of this predictor variable, the log of odds, keeping all other variables constant. Keeping all other variables constant, here there is only one variable, but assume here you have age, fixed obligation to income ratio, other model variables. Keeping all other model variables constant, the coefficient of LTV is saying that for every incremental unit change in LTV, the log of odds will increase by this much. This is just a technical explanation of the coefficients parameter. And if the log of odds, if the coefficient is positive, which means the default will increase for every incremental unit change. Great. I think so. We have covered a good amount of logistic regression in this 1 hour, and I have tried to give lots of detailed understanding. I've tried to explain at a very high level hypothesis, importance of hypothesis testing. I've tried to explain the how to go about calculating the p-value, the importance of the coefficients, the sign of the coefficients. Okay, then visualization, how you relate the output with the visual in a very short 1 hour of this workshop. I really feel you would really find this 1 hour very fruitful and worthy of being part of this workshop. Any questions? Sharad, any questions?
So for this, if the number of variables are less, then it's okay, then it's feasible in Excel, right? But when the number of variables after transformation, they go very high. So do we have any automated code or something for this, or can we write that?
Yeah. See, all of this, what happens is in companies, all of these steps happens through automations. Okay. They are
Okay.
not done in Excel, and there are lots of automated codes. Okay. When I do my own consulting projects, okay,
Okay.
so for those, when my team goes, we don't keep doing these things in Excel. We have automations and
Right.
we've got lots of other automation things that we do, right? Otherwise, it would be difficult to build model.
Right.
So automations are must.
Okay.
Automations are must.
All right. So, sir, will it be a part of this session, or
No.
are we planning that in the future?
So those are not part of the session because see, in session this is a 5 hours overall. Uh, if I go very detailed step by step of logistic regression, there are many steps. Okay, there are many steps of logistic regression. It would take probably a 15 hours entire training. Okay. So, but at in a 5 hour crunched workshop, I'm trying to give the important concepts.
Got it. Got it.
Yeah.
Yeah.
Hey, for the target variable, I mean, you have a default, no default.
Yeah.
What percentage default or non-default for the imbalanced data, consider imbalanced data? What percentage is the minimum percentage of default or non-default to build the model?
This is for if you are using a logistic regression technique. Logistic regression technique can easily build model on unbalanced or imbalanced data sets. The challenge of imbalanced data set comes in classification regression technique, classification tree technique. Okay. But for logistic regression, even if I got a default rate of 0.5, 0.05%, or 0.5%, I can go ahead and
Okay.
build a model. What is important is the absolute number of defaulters or the absolute number of the target value 1 should be minimum 300 to 500 in the model development dataset. In that case, even if the default rate is 0.5 percentage, I can build a logistic regression, but the absolute number of defaulters I require anywhere in range of 300 to 500.
Because whenever the defaulter, it will be less than 2 or 3%,
Yes,
if I'm
yes,
not
yes.
wrong.
Yes, it would be less. It will be less.
So for that, logistic is the best one. I mean, I do understand depends upon.
Logistic regression, neural networks, these techniques are best. Classification technique will not be good.
Okay. I mean, you're talking about the neural networks, that's ANN, right?
Yeah, ANN. Even ANN can do it.
Okay, got it.
Predominantly, but in banking, always it's logistic regression.
Okay, got it.
I have one question.
Yeah.
Sharad had asked if there are multiple variables that are there,
Yeah.
and if you want to predict which variable is impacting the target outcome.
Yeah.
So right now we went one by one for
Yeah.
gender, and then we explored.
Yeah.
So in normal, like a practical scenario, how would we shortlist the list of variables that need to be even considered for whether we want to take it up for verification or not?
So there are multiple approaches. One approach is basically you go with a business opinion, business gut feel. Based on your past experience, you know these are 5, 6, 7 important variables which will come. But however, when we go completely statistical process, there's something called as weight of evidence, information value, weight of evidence concept. So you typically use information value, weight of evidence concept. Okay. Then there's something called as variable clustering approach. So there are multiple approaches by which you can really reduce the number of variables and separate out, remove out variables which are insignificant upfront.
So in banks, what do they? What specific technique do they use?
Banks make use of weight of evidence, information value, variable clustering. Okay, these approaches, and again, banks have their own natural wisdom because you are in a bank. You will know, or as a consultant, you have worked with many models. You will know at least these 10 variables are you have seen. For example, I have built more than 100 plus predictive models in my career. Okay. So if I am given any problem statement, I can upfront say these 5 variables should be there in your model, right? So now when we build model based on experience, we know that these variables cannot go, these cannot be dropped, right? So they have to naturally come in. On top of that, we'll definitely use statistical process to see which are other variables which are due to time and change in business scenario, economic scenario, which other variables are now coming up significant. So we use statistical procedures like IV, weight of evidence, variable clustering to reduce the number of variables.
Okay.
Yeah. Okay, if there are no further questions, then we can end the workshop.
Yeah.
Yes. Thank you, sir.
Thank you, everyone. See you tomorrow. Tomorrow, our session is at 8 p.m. Reminder. Okay?
Okay.
Sure.
All right.
Bye. Take care. Good night.